Okay, so let's look at introduction to biostatistics. Um, by definition, biostatistics is a branch of statistics that deals with the collection, analysis, interpretation, presentation, and application of data in the context of the biological and health-related research. So there are about five things biostatistics does. It has the aspect that has to do with collection of data, analyzing the data, interpretation of the data, presentation of the result or the data, and the application of the data in the context that has to do with biological sciences. In other words, any health related statistics can be described as biostatistics. It involves the use of statistical methods and techniques to analyze data now obtained from biological experiments such as clinical trials, epidemiological studies, and other areas that involves healthcare or life sciences. Now, like I mentioned in class, when you're carrying out biostatistics, one of in the area of clinical trials, so the application can be seen in clinical trials where you're testing the efficacy of a drug. In other words, you have to recruit people that you want to use, volunteers that you want to use, of which we pay them at the end of their research. Okay, then you're going to divide these people into two depending on your design of the work, and then when you divide them into one part, you will be given the test drug, the other one will be given the placebo. Placebo are drugs that do not have the active ingredient, so people will take it and then you monitor the effect, and after that you analyze your result and you come out with whether the drug is effective or not. Now, divisions of biostatistics. Now, biostatistics can be divided, has about six divisions. The first division is the descriptive biostatistics, which has to do or focus on summarizing and describing data using various statistical measures and techniques. It involves methods such as calculating the calculating measures of central tendencies, something like the mean, the median, the mode, or measures of dispersion, which has to do with variance, standard deviation, standard error of mean, and all those. It also has to do with graphical presentation of the data. Now, we have the inferential biostatistics. This division involves making inferences and drawing conclusions about a population based about the population based on the analysis of a sample. It includes hypothesis testing, confidence interval, and regression analysis. Inferential biostatistics helps in making predictions and generalizations about large population based on the limited data. So in inferential, you can use a small population to carry out the work, and then you can now infer that the result can be applied to the general population. For instance, you want to carry out the research in FUNAI, you might not necessarily use all the students in FUNAI to carry the study. So you're going to use a small population, and at the end of the day, you're going to infer. Now we have the clinical biostatistics. Now this division is specifically concerned with the design analysis, and interpretation of clinical trials and studies. It focuses on determining the efficacy and the safety of medical intervention, treatment comparison, and patient outcome. Now, clinical biostatisticians play a crucial role in designing robust clinical trials and analyzing the results of the data. Now, we have the epidemiological biostatistics, and you know that epidemiology is the study of patterns, causes, and effects of health and disease condition in a population. So, the epidemiological biostatistics combines the statistical method with epidemiological principles to study disease occurrence, risk factors, and public health intervention. Now, in epidemiology, you statistics, you begin to use the principles involved in epidemiology to make the design of the work and even make your inferences. Okay, now it involves analyzing large scale population data, calculating disease rates, and identifying associations between risk factors and the diseases. Now, when you work with something like WHO, they have their own statistical package. I think they call their statistical package AP Info. It is designed for epidemiological studies. Now we have the genomic biostatistics. This division deals with the statistical analysis of genetic data and its application in genetic research. Genetic biostatisticians develop and apply statistical method to study genetic variation, hereditary, gene to gene interaction, and genetic association with diseases. They work on complex problems such as genome wide associated studies and genetic link analysis. Now, finally, we have the environmental biostatistics. This division focus on the statistics and statistical analysis of environmental data and its impact on human health. It involves studying the relationship between the environmental exposure such as air pollution, water contaminants, and health outcome. So environmental biostatisticians use advanced statistical techniques to model exposure response relationships and assess the health risk associated with the environmental factor. Now, when you look at all these divisions, there is one thing they have in common, and that thing they have in common is trying to bring a relationship between whatever statistics you're doing to health, to yeah, to health, okay, or life science. Let's continue. Now, what are the importance of biostatistics? One, biostatistics is important in study design. So we say that statistics play a crucial role in designing studies and experiments to investigate various research questions. It helps in determining the appropriate sample size, randomization techniques, and study protocols to ensure reliable and valid results. So, for instance, you want to do a work in a if nine, like I mentioned, and this work have to cut across the whole school. So, how do you randomize? How do you get your number? How do you just go and take 20 people? At the end of the day, is 20 people enough to generate a data that can be applied in all the students? So that is why we said that biostatistics is important even in the design of the experiment. Number two, biostatistics is important in data analysis. So biostatistics provides the tool and techniques to analyze complex biological and health-related data. It enables the researcher to identify the pattern, the relationship, and the association between variables, which helps in drawing meaningful conclusion and making informed decision. So, number three, the importance, we have mentioned it before, is also in clinical trials. And we say that biostatistics is essential in designing and analyzing clinical trials, which are crucial for evaluating the safety and efficacy of new drugs or new treatments or new interventions. It helps in determining the sample size, the randomization process, and the statistical tests. Okay, so when you're doing clinical trials, sometimes you will find out the reason why you're going to use a T test or a Z test, okay, or a root test, any of the tests that has to do with clinical trials. Now, four, we say that in epidemiology, biostatistics is fundamental in epidemiological studies that investigates the distribution and determinants of diseases in a population. It helps in estimating disease prevalence, calculate incidence rates, and identify the risk factors, thereby aiding in public health planning and policy making. Now, it's also important in risk assessment. Biostatistics is used in assessing the risk factors associated with diseases, environmental exposure, or genetic predisposition. It helps to quantify and the magnitude of risk and determining the probability of adverse outcome, which is crucial to prevent or measure and intervention strategies. Now, in this, you find out that biostatistics is very, very important in risk assessing. For instance, when the coronavirus broke out, it is the biostatistics that can look at the patterns. They can look at who is affected. During that period, I saw in China where people are just falling and dying. Now, it is the biostatistics statistician that can look at the trend and begin to associate, okay, this one that happened like this is as a result of so and so virus and so on, due to the data that is available to him. Now, biostatistics is important in decision making because it provides a quantitative framework for the decision making in healthcare. In healthcare, you don't just rush and begin to make decision. No, you must have a data that you have analyzed before you make a decision. For instance, even in AE a time came, they called a meeting of all academics, and what they were discussing was dress code. So somebody made a statement. The person said, have we actually researched and we find out that the problem in AE is dress code? And the person said yes, and he asked the person, how did you do the experiment? What data did you use? Because for you to make a decision in any research at all, you must be able to generate data. And because you're doing this decision making with biological samples, a biostatistician must be involved. Now, the last one is data visualization. Biostatistics enables the visualization presentation of data through graph, charts, and other visual tools. It helps to present complex information in a clearer and concise manner, facilitating better understanding and communication of the research findings. Okay, now let's go into the basic or the basics of biostatistics. And simple put, I will say that the basics of biostatistics is the data. Okay, so by definition, what is data? And we say that data refers, sorry, let me zoom it. Data refers to any information or facts that can be collected, stored, and processed. It can exist in various forms such as numbers, text, images, audio, videos, or any other type of digital content. In the context of the computer science, the programming, computer science and programming, data is typically presented and manipulated using codes. Okay, so but the collection of any information gives you the data. Now let's look at data sources. There are two sources of data. You have the primary source and you have the secondary source. Now, the primary data refers to the original data collected firsthand by a researcher for a specific purpose. It is collected through survey, interviews, observation, experiments, and direct measurement. Now, most of the times, this primary data or primary source data is called, most of the times you call it your raw data. Okay, so it's the one you have collected firsthand, and we are saying that primary data is considered more reliable and accurate as it is collected directly from the source. Now, we have the secondary source. Secondary data, on the other hand, refers to the data that have been collected by someone else for their own research and purposes. It is obtained from sources such as books, journals, websites, government research, databases. The problem with secondary data is that it is less reliable compared to the primary data, as it may not meet the specific need of the research and may have limitations in terms of accuracy or relevance. Now, because this secondary data is a data that you collected for another study, another experiment, another hypothesis, okay, that same thing cannot be as accurate as the primary data. Okay, now what actually is the difference between primary data and secondary data? Now, the differences can be seen in the collection method. So, primary data is collected directly by the researcher, while secondary data is obtained from already existing sources. Another difference can be seen in the purpose. The primary data is collected for a specific purpose, specific research project, while secondary data collected from a different purpose and later used by the researcher. Now, when we look at their reliability and accuracy, primary data is considered to be more reliable and accurate as it is collected firsthand by the researcher. Then the secondary data might have limitations in terms of accuracy and reliability, as it cannot, as it was not collected specifically for the research project. So if somebody has done a work, for instance, last month my student did work on traditional sex enhancers, but they were collecting data from the works that was done with another kind of sex enhancer or another type of traditional or herbal sex enhancer. Now, those data they collect, we cannot really trust them because they are not looking at the things that we are actually looking at. So it will not really be be reliable in terms of the research we are doing. It might be reliable for the person that did it, but for me, using it as a secondary data, we might not really rely on such data. Now, another difference is the cost and time. Primary data can be time consuming and expensive because it involves designing research instruments, recruiting participants, and conducting surveys or experiments. But secondary data really is readily available and can be accessed at low cost at a shorter time frame. You can just go into the internet and the data that you want to use is already there. In as much as you use it, it does not mean that those data that you get from internet are accurate. Okay. Number 5, the specificity. Primary data is specific for the researcher's research question and objective, but secondary data may not always address the exact research need of the researcher and may require additional or analysis or interpretation. Now, let's look at categories of data. Since we are looking at data, there are different categories of data which we are going to look at. Number 1 is numerical data. Numerical data consists of quantitative values or measurements, and these numerical data can be further subcategorized into two. You have the discrete data, and these discrete data represent the values that are distinct and separate, such as the number of students in the class, the number of cars that parks in the parking lot. Now, these values will always be in whole numbers. It cannot be subdivided further. There is nothing like 1.5 car or 1.5 students. Now, there is also a continuous data. The continuous data represent values that can take numerical value within a range. For instance, the height of individuals, the temperature of a room, and so on. So you find out that these ones might not necessarily be in whole numbers. Okay, so it is continuous data can be measured and subdivided into small units. Now we have number 2. We talk about categorical data. Now there are also two types or two subdivisions of this categorical data. You have the nominal data and you have the ordinal data. Nominal data represents categories that are unordered and have no inherent ranking. Example includes gender. Gender can only be male or female. Okay. Marital status, favorite color, and so on and so forth. So when you're carrying out a statistical analysis, especially when you be using something like XPSS, when you're coding, the software will be asking the type or the category of the data that you, whether they are ordinal, whether they are nominal. Now, ordinal data represent categories that have specific ordering or ranks, which includes something like educational levels, whether it's primary, middle school, high school, college, or so on, or something like ranking: poor, fair, good, excellent. Okay, now when you look at it, you have to be careful when you're looking at this separating ordinal and nominal. So these ones represent the categorical data. What category is this data? Now we have the another number 3, we have the time series data. We say that it represents values that are collected over a specific period at regular interval. It is used to to analyze trends and patterns over time. Example, stock price, monthly salary figures, or weather data collected daily. Okay, those ones are time series data. Now you have the text data. Text data consists of unstructured information in form of text, such as email, social media posts, articles, or customer reviews. Okay, now analyzing text data involves techniques like natural language processing and text mining to extract the meaningful insights. Now let's continue. We are going to look at types of data. And I've told us in class that the types of data includes those categories. Those categories can also be part of text. Those categories can also be part, okay, of the types of data. So we have the nominal data, the categorical data, the time-based data, the database data, and then we include the spatial data. Spatial data refers to data that is associated with specific geographical location and coordinates. It includes information such as the latitude and longitude, addresses, or boundaries of region. So spatial data is commonly used in the fields like geography, urban planning, and in environmental studies. So now the question is, if you're using a data in geology in geography, how what has it got to do with biological sciences or biostatistics? You will find out that a biostatistics can go to specific areas to collect data. So the site of the study area is quite important, and that is where the spatial data comes into play. Now, lastly, we have images and videos. Images and videos consist of visual information such as pictures, videos. Analyzing image and videos the data involves techniques like computer vision and image processing to extract further patterns that you need. So these six are the different types of data that we can use. So now let's look at the method of data presentation, or even your result presentation. Now in data presentation, we are going to look at number one is the tables. And we say, when the picture there shows the picture of a table, and the table presents data in a structured format with rows and columns. They are useful for organizing and comparing different variables and categories. Tables can be simple or complex depending on the amount of data that is presented. Now, down, I want to see if I can show us something. Okay. Now, there are things that you must see in a table. One is the title of the table. Okay. Two is that the table must contain three horizontal lines, especially when it has to be with results. Another way we present is in histogram. Histogram is used to present a distribution of numeric data. Okay, they display the frequency or count of a data within a specific interval of being. Now, when you look at the histogram, It's made up of bars, but these bars are not separated. The bars are joined together. Okay, when you look at the frequency and the variable values, so you can show you a distribution. Are we following? Yeah. So the distribution can be seen with histogram. So we can present our data in form of histogram. We can present our data in form of map. Yes, Google Map is now very important, especially when you're doing an environmental studies. You should actually bring a map of the location. So we can pause here and then continue next time to avoid this being too bulky.